Welcome to Earthquakes Part 2. There is a lot of fiction that is related to earthquakes. People have very interesting beliefs about earthquakes. One of which is earthquakes usually happen in the morning. Earthquakes happen any time of day. There's no pattern. There's a fiction that there's earthquake weather, but there's no connection between the weather and earthquakes. The earthquakes happen far below the Earth's surface, so weather has nothing to do with it. Another fiction is earthquakes are on the increase, but we're getting better at detecting them, so it seems like there's more. Another fiction is that we can actually prevent earthquakes from happening. We can't stop the convection going on inside the planet that is making the plates move. That can't happen. If that happens, we will all die. So we cannot prevent them from happening, but you can protect yourself if you live in an earthquake zone. This map shows the incidence of earthquakes in different parts of the United States, and you can see that California has quite a few earthquakes in it. But also look at southern Illinois. That's where the New Madrid Fault is. This shows where there have been specific earthquakes, and if you look here, this is right near St. Louis. This isn't near Memphis, and this would affect us here in Illinois. And if you look here on the west coast, you can see where they are occurring along that fault line. And obviously Alaska is along a fault line because look at how many earthquakes occur there. There's many in Hawaii as well, but we know there must be some type of subduction going on because there's volcanoes in Hawaii. Puerto Rico also has incidents of earthquakes. So there's two terms that we use when it comes to an earthquake: the epicenter and the focus. The focus is where underneath the surface the actual earthquake occurred, and that's where the seismic waves come from. And then whatever point is on the surface above that is what we call the epicenter. So earthquakes actually move through the Earth's crust in waves. There's three types of waves. So each wave has a characteristic all its own. Okay, there's three types of waves. There's P waves, there's S waves. That's for the body of the earthquake, and then here on the surface you can have Rayleigh waves or love waves. So you can see the way they move. We're going to talk about that a little more. So there's P waves. Primary waves are longitudinal waves. They move from left to right. They move through the crust much faster than any other wave. Scientists are actually trying to detect these waves because it can give people a little time before the S waves occur. The P waves do not cause damage. They move very fast. They are push-pull waves. They are longitudinal waves. They push rock particles into the particles ahead of them, and they bounce back, and just like a slinky, moving back and forth in a longitudinal wave. The secondary waves, S waves, these are the dangerous waves. They don't go through the crust as fast as the P waves do. And these are transverse waves. They move up and down. And these are the waves that cause such terrible destruction in an earthquake zone. So the slowest moving seismic waves are called surface waves, or L waves. They arrive at a point after the primary and after the secondary waves do. They start at the epicenter. They move along the surface of the earth just like waves in water. They don't go down into the earth, and they cause the most damage, even more than S waves. This is a picture of a seismograph. A seismograph is an instrument used to record energy released by an earthquake. The needle actually stays still, and the paper beneath it moves. When it's moved by the ocean of the earth, it creates a wavy line. If we look here, we can see the blue P waves, the primary waves, followed by the red S waves, move outward, just like if you dropped a pebble into water. you had the first waves and then the second waves go out. So this shows you what that looks like when there's an earthquake.